In this video, we get to talk about the red planet, also known as Mars. Mars is named after the Roman god of war, known as Ares in Roman mythology, probably because of its red color. If you can see Mars in the sky, it is pretty small, but if you can see it, you can actually see, even with your eye, without binoculars or anything, that it is a nice red color. You can see that surface color. So some information about Mars, it's kind of the basic numbers for Mars. Mars is further from the Sun than we are, about 150% of our distance, right? 1.5 astronomical units from the Sun. In terms of size, Mars is pretty small, about half of an Earth's radius. In terms of mass, it's only 11% of Earth's mass, so fairly small, not very massive. Mars is mostly rock with some metal. You can see that reflected in the lower average density than we've seen before. And look at that temperature, 220 degrees Kelvin. That's really cold. Okay? In Celsius degrees, that would be about -50. That's really cold. Okay? People don't realize how cold it is on Mars. It's extremely cold. We're talking below zero, right? 0 degrees Celsius is when water freezes. So this is 50 degrees below where water freezes, right? So sub-freezing temperatures. Really cold out there on Mars. Mars does have some things that are going for it in terms of colonization, though. Okay, does have a thin atmosphere that's mostly carbon dioxide. So that's not really a great thing. But it does have a rotation period, right, or a spin rate of about an Earth day, right? 24 hours and about 40 minutes. So that's pretty close to what we're used to, right? That's kind of one of the good things about living on Mars, would be your daytime and nighttime cycles would be very similar to what they are on Earth. It's also got its axis tilted pretty similar to Earth's axial tilt. About 25 degrees as opposed to our 23.5 degrees. So very similar. And remember, our axial tilt is what gives us seasons. It's going to do the same thing on Mars. So Mars actually has seasons that are very comparable to Earth's seasons. They're a little longer because Mars takes longer to go around the Sun, so divide that longer time by 4 and you get longer seasons, but they'd be very similar to the Earth seasons that we have. Because there are those seasons, you'll see the ice caps in our various pictures here will grow and shrink. You can see it looking pretty small right there. This happens on our Earth as well, right? The ice caps will grow in winter and then shrink again in summer. This orange color that we're seeing, kind of this red-orange color, is rust, right? Iron oxide. This iron oxide we think formed back when the planet was a little bit wetter, right? And as that water evaporated, we were left with this kind of rusty colored dirt that's on Mars. Mars does have evidence of past volcanic activity, and we'll look at some of that, as well as its evidence of past water activity. So the atmosphere of Mars, I said it was mostly carbon dioxide, but there's not a lot of it. Okay, so just like Venus, mostly carbon dioxide, but unlike Venus, it's a very thin atmosphere. So the heating effect that you're going to get from that mostly carbon dioxide atmosphere is really, really small. Okay. There are times when you look at the planet and you'll see the haze covering up the planet. This happens during certain seasons. These ice caps up here are not water ice. They're actually carbon dioxide ice. And carbon dioxide is what we know here on Earth as dry ice, right? You can buy it at various stores, fun for Halloween. But like dry ice on Earth will go straight to the gas phase, right? It's a solid and then it goes straight to being a gas in a process called sublimation. That happens on Mars. So that ice cap up there is kind of in this symbiosis cycle with the atmosphere. That ice cap will give off carbon dioxide that goes into the atmosphere during the summer. Then during winter, that carbon dioxide in the atmosphere is going to freeze back down on that ice cap. Occasionally you'll see Mars where you won't see these dark parts. That's when it's having one of its big dust storms. And those big dust storms, it looks entirely red, like a nice big red ball. There may be a picture in here of that. Trouble for the rovers, right, when it's got those big dust storms. And we do have a lot of rovers that are up there. In the 70s, we sent the Viking 1 and 2 landers, not as sophisticated. In 97, we sent the Pathfinder lander, a little guy named Sojourner. Right, there he is right there, that's Sojourner. Pretty small, but exciting, right? He got to rove around a little bit. In 2004, we got the twin rovers, the Mars Exploration Rovers Spirit and Opportunity, and then in 2012, Curiosity landed. The next big thing that's coming, probably, would be human exploration of Mars. There's a private company that's working on that, as well as a project with NASA. Their Orion mission is supposed to be a manned craft to take people to Mars. We'll see if that happens. So let's take a look at those rovers. Up first are our Spirit and Opportunity rovers. One of these rovers is still operational, which is amazing. Look at that date, 2004. These rovers have been up there for a long time. They were designed for a mission that maybe covered a few months. It's been over a decade now that Opportunity has been operational. Spirit lasted a good 6 years before it didn't respond. Spirit was in an area where it got a little bit too cold, and often they winter over, and then when spring comes, they'll thaw the rovers back out. The rover will come back to life, no problem. Spirit didn't survive the last wintering there in 2010. Kind of a bummer. We do have a new rover up there right now. That is our Curiosity rover. That's the big guy here. I'm sure you've seen pictures of it. The operational part of Curiosity is this piece here that's resting on the ground. This is its arm. This is where the drill is and all of its exploration tools. Up here on this masthead, we just have a camera, or a few different cameras. But this is the business end here of the rover right here. You can see all of these rovers have the same rocker bogie design, right? The wheel design. This here is the Mars Exploration rover, either Spirit or Opportunity, and little guy, Sojourner. Curiosity is much, much bigger. So you notice Sojourner and the Mars Exploration rovers have solar panels. Curiosity's power needs were too big. Those dust storms on Mars make the solar panels not quite as efficient as they need to be to drive a rover that size. So Curiosity is actually nuclear powered. That's what you're seeing out here in this back end, is that's where its nuclear fuel source is. And then it heats up some material and you get a thermonuclear coupling device to drive that rover. So what have these rovers discovered? Well, let's talk about some of the features that are out there on Mars. So Mars does have some giant volcanoes, and you can see them very nicely in this picture. Again, what kind of volcanoes are these going to be? We're going to see these are shield volcanoes, right? Remember, we're only going to get the composite volcanoes that we have on Earth when you have some sort of plate tectonics. Mars doesn't appear to have had plate tectonics. Mars also has a really lovely valley. This valley is gigantic, right? You can see this big scar that goes across the face of Mars here. Remember, Mars is about half the size of Earth, so this scar here goes quite a bit across just this picture here of Mars. In fact, if you were to take this valley and put it on the continental US, it would go from LA to New York City. That's a big valley. Not only that, but it's 3 times deeper than our own Grand Canyon, right? It's just a massive valley. This valley, you'll see, is named after the Mariner mission, right? That's why they call it the Valles Marineris, or Mariner Valley there. Mars, of course, it's a terrestrial planet, also has some impact craters, but depending on where you're looking on Mars, you'll see either very few or a lot of craters. A little bit like the Moon, there are areas of Mars that have been resurfaced much more recently than that heavy bombardment period. So the geology of Mars really depends on what hemisphere of the planet that you're on. Okay, up in the northern regions, we're seeing really smooth terrain, lower land regions. Down in the southern regions, though, we're seeing kind of like the lunar highlands, right? These are Martian highlands down in the south. These are older terrain, much more heavily cratered. The theory going is that those northern regions where it's nice and smooth It's smooth because maybe there was water there. When we look at the edges where the highlands meet the lowland areas, right along these edges in here, we actually see there are areas that look like deltas, right? Like the Mississippi Delta, where that empties out into the Gulf of Mexico. We're seeing features that are very much like that. Okay? One of the big things with looking at Mars is they look for things that are analogous to properties that we understand on Earth. They'll go through all of our photographs of Mars and look for traits that are similar to what we see on Earth. We see on Mars big volcanoes. These volcanoes are no longer active, but they're really, really big. In fact, Mars has the biggest volcano of the entire solar system. This is Olympus Mons, or Mount Olympus. It's a little hard to tell from this topographic kind of looking down at the mountain how tall it is, but if you look at this inset over here, Olympus Mons is really, really tall. Compare that to Mauna Loa out in Hawaii, right? Our big shield volcano. It doesn't even compare. Okay. Now, one of the things this tells us, because this volcano got to be so tall, this means likely a couple of things. One, the surface is not moving. There's no tectonic action, right? This isn't a volcanic chain like we have on Earth. Two, the crust of Mars must be really, really strong, right? You've got a big mound of dirt that's now on top of the crust. The crust has to be thick enough then to support that mound of dirt without collapsing back in. When we look at Hawaii, actually the mound of island gets so heavy that it will crush in on the surface a little bit, and you get a tiny little moat that develops around the island, right, as that kind of pyramid, or if you will, of dirt sinks back into the crust. We don't see that on Mars. That crust must be much thicker than the crust we have on Earth. Olympus Mons isn't all alone. It's right next to the Tharsis Rise, where we've got all of the rest of these big volcanoes here. Just kind of an interesting area. And just over here, this is just the start of that Mariner Valley right here. We believe that the Mariner Valley happened because of the volcanic activity on Mars. The crust would have solidified. These volcanoes would have made pressure from underneath that crust, kind of pushing out on that crust, and the crust would have cracked, making that Mariner Valley there, right? So different than our Grand Canyon, right? Grand Canyon's all river action. This, we think, is a more geologic process than that. That'd be plate tectonics, right? Our volcanoes don't get that big because the plate keeps moving, right? So you get multiple volcanoes rather than one big one. Let's talk about that water on Mars. This has been some of the most exciting stuff that's come back from those rovers. This was one of their main goals, was to try and find water on there. It'd be great for human exploration if there was water there. But really, what we want to find out is, there's a couple of things. How did Earth get its water? Right? Maybe if we can find out if Mars had water and compare that water to our water, we can trace it back to the source. But we also think that water is a key component for having life on a world. So there's the potential, if Mars had sufficient quantities of water in the past, that maybe Mars once had life on it. That would be a very exciting thing for scientists, because we also want to find out, how did life start? How did Earth get life? If we can find out that maybe it happened somewhere else, and maybe that planet had roughly the same conditions that our primitive Earth had, then we can tie the development of life to those conditions. So let's take a look at some of that hidden evidence for water on Mars. So a lot of this evidence is pictorial, right? Looking at this picture, I know it's pieced together, but looking at this picture certainly looks like there was some sort of flowing water through this picture. This one's a little bit more obscure. This, you're seeing some collapsed subsurface water. Okay, so this is like the sinuous riles that we talked about with Venus. There was water under the surface. As that water flowed away, the top of the cavern that the water was in then collapsed back down. We do see this kind of thing on Earth as well. This is one of my favorite pictures of the water evidence. This is a splash crater along with a little riverbed. So if you look, this is a crater here, okay? But just around that crater, looks like that when that came down, it made kind of a splash. All right, imagine a nice big kind of area of mud, right? And you drop a big rock into that area of mud, right? It's going to splash that mud out, right? That certainly looks like what happened here. I love that. I don't know how else to explain that, right, other than water being there. Here's a nice gully, right? Water flowing, right? Out it goes. Again, looks a lot like what we see out there on Earth. And here is that channel. We saw a piece of it in the other photograph. This is more like the Grand Canyon, right, where we've got a channel that's cut down, and you can see in the very inside there what looks like a little riverbed down in the center. Also, if you look at the sides, it looks like it's got some sedimentary lines there. Okay. And in fact, that's one of the best pieces of evidence for water on Mars. When our rovers went out, the Opportunity went to an area there, and it saw these. Okay, these have been nicknamed blueberries, but these are hematite concretions. Hematite is an iron compound, and when it forms with the presence of water, it'll form into these little spheres. Now, you'll notice in this bottom photograph, these spheres of hematite seem to be in a layered rock, right? You see those layered lines? Okay, they look like strata. Okay, those layered lines probably mean this is a sedimentary rock. Okay, and in fact, when they studied the rock that was there, they found that it had the salts that they found in ocean rock, kind of old ocean beds here on Earth. So very exciting, right? You've got sedimentary rock and these blueberry concretions, right? These hematite concretions that only happen in the presence of water. So seems like this has got to be, right? This has got to be it, right? We've got to have had water on Mars at some point. Here's another up-close look at that. Is there water there today? Well, yes and no. There's no liquid water on Mars, but there was in the past. In the past, we think that there was enough water to cover maybe half of the planet or more. There was enough water for there to be rainfall and things like that. Right now, there's no liquid water, but there probably is lots of frozen water, right, or water ice. Some of it will exist under the surface of Mars, right, underneath the dirt, just like we have water underneath our soil, right? That's why you can drill a well and get water. Mars would also have that, but it'd probably be frozen. Okay, so we've got some subsurface frozen water, but we also probably have some up in the ice caps. Okay, so this is a really good potential for sending people up there, right? We know people need water. People need, comparable daytimes to what we have on Earth, right? Seasons we think are needed for growing crops and things like that. So pretty exciting for exploration purposes that it would have water. Let's take a look at those ice caps. Okay, those ice caps, like I said, are mostly carbon dioxide or dry ice, a little bit of water ice, but mostly carbon dioxide ice. And if you look at the ice caps, they have kind of a layered feature, right? You can see some of the stripes in here. That's because of those big dust storms that happen. Okay, as that carbon dioxide ice evaporates out, maybe you have a big dust storm that comes and layers a nice big layer of dust over the existing ice. Then you get the carbon dioxide ice to freeze back down, and you get a layer, kind of a sandwich of dirt, ice, dirt, ice, dirt, ice, dirt, ice, and you get these kind of layering effect that you're seeing here. Mars does have two little moons. They're not quite as nice as our moon, I don't think, but they're kind of cute. Those moons are Deimos and Phobos. These are the suns that accompany Ares, the god of war, into battle. So these are them. There's Phobos and Deimos. Phobos, I think in this picture, looks a little like the Death Star. But notice cratering. Okay. Notice the irregular shape on both of these guys. These are thought to have been little asteroids. These little asteroids probably got a little bit too close to Mars, and they got captured into Mars' gravitational pull. Now there are moons that go around Mars. Because they are so close to Mars, they actually will rise and set multiple times within a night. Right? They're going around pretty fast. If you look at Mars and the moons, they're really, really small. They're actually in this picture. Probably can't see them, but there's one right there. Okay. And there's one right there. Well, those are them right there. They're just tiny, right? To give you a comparison, in diameter size, right? Not even a fraction of the moon's diameter. These are just really, really tiny, tiny little moons out there.